In this next section, we're going to look at the area under a curve, and we're going to start by looking at area approximations. We want to find an approximation to the area between the curve, and this curve here is y equals x cubed plus 1, and the x-axis from x equals 1 to x equals 4. We're going to use these rectangles, which are called left rectangles, shown in the diagram below. So why are they left rectangles? Well, the height of the rectangle is the height of the curve at the left hand end. You'll see shortly we're going to use some right rectangles. Why is it an approximation? Well, the true area would be everything under the curve from here to here. And you can see that these bits of areas will not get counted. Okay, so let's do the approximation. What we want to work out is the area of those rectangles. So I'm just going to save a bit of time by using the calculator. I'm going to go to graph and table, and I'm going to put in there x cubed plus 1. And I'm going to generate a table, and I am going to start my table at 1. I'm going to take it to 4. I don't need 4 for this first part, but we will need it shortly. With a step of 1, we can see all the rectangles are 1 unit wide. And so we have x and y. So when x is 1, y is 2. When x is 2, y is 9. When x is 3, y is 28. And when x is 4, y is 65. So if we look at the very first rectangle here, it has therefore a height of 2 and a width of 1. The next one has a height of 9 and a width of 1, and the next one a height of 28 and a width of 1. So the area, and I'll call it area L for using left rectangles, area left is going to be 2 plus 9 plus 28, giving me 39 square units. Okay, so now we're going to find an approximation using right rectangles. And the reason these are right rectangles is because the height of each rectangle is the height of the curve at the right-hand end of the rectangle. So we can see that this first rectangle is going to have a height of 9. Then the next one would be 28, and the next one would be 65, just using the values from the table up here. So my area this time is going to be 9 plus 28 plus 65. So 9 plus 28 plus 65 is 102 square units. So we can see that these two different estimates are quite a long way apart, 39 and 102. State two ways that we could get a better estimate of the area under the curve. Well, if you think about the first one, we already mentioned that we've got some area that we didn't count, and that's why that one's a huge underestimate. This one's a huge overestimate because we've got area above the curve that we counted. Now you could reduce those amounts in both cases by using more rectangles. So go for much thinner rectangles, basically. The other way is to average our results. We know the first result was an underestimate, the second result was an overestimate. So let's do 39 add 102 divided by 2. So 39 plus 102, divide that by 2, and we get 70.5. The true area, which we find by integration, and that's coming, see later, is 66.75. So even with this small number of rectangles, very crude estimate, it's not that far out.